Okay, let's look at question 2b. Find all times in the interval from 0 to 3 when the particle changes direction, justify your answer. So, when we look at this question, what should be going through your mind? Well, you should be thinking about, when does a particle change direction? What tells me a change in direction? And hopefully you remember from 2a that a change in direction occurs when the velocity changes. So when the velocity changes in its sign value, we have change in direction. Okay? So when does this happen? Well, and more importantly, what's the easiest way to do this? Well, I guess you're gonna hear me say time and time again, the easiest way to do things, and you can use a calculator, is to just simply graph it. So you're gonna see here that I graphed the function. I also want to stress that I also put y equals 0 there, because when it crosses that point will be when there's a change in direction. So what happens when we graph this? Well, what you'll notice here is that, first off, when you initially graph it, you'll be at the standard window. And you want to, if you go to the standard window, let me change the color here. Right here, if I go to the standard window, the default is negative 10, 10, 10, 10 for the x's and for the y's. It's in your best interest to change your window to what it's given. So they ask you between 0 and 3. A lot of times, if you don't do this, you get this really freaky looking graph that goes all over the place. And you may be looking at a picture that doesn't pertain to what the question's asking. So I'm not saying this is the case for this one, but let's say the graph goes like this, and this is at, let's say, 4, and this is at 5, and this is at 7, and this is at 10, right? Well, if I'm looking at a picture like this, I may think that the graph is crossing this 1, 2, 3, 4 times, when in fact, I only care about what happens in a section like here, right? I guess this should be like 2, so it makes sense, right? Because it crosses at 3. But you get the idea. So you want to look at a picture that deals with what the graph is, what the problem is specifically talking about. And you want to be as careful as possible not to overwhelm yourself with information. You only want to deal with the information that is relevant to you. So upon doing so, you get a picture somewhat like this. The color calculator, I'm using color calculator because it really helps you to see the lines. Obviously, the blue is the function, the red is is y equals 0, and this is the point of intersection. Hopefully, everyone here knows how to find points of intersection, right? We just go under second, calculate, click under intersection. You'll click, the cursor will show up. You click one point to the left. You hit enter. Another cursor is going to show up. You go some point to the right. It will be along the line y equals. And hit enter, enter, and you'll get your intersection. And in this case, my intersection is 2.707. So my final answer, going back to the question, I'd answer this. The particle changes direction at t equals 2.707 because v of t has a sign change there. That's it, folks. There's your answer. Okay? Hopefully that makes sense. See you all in the next video.